And when we multiply by 5, we get 360. That would be number 10. Number 11 is just an open-ended what's the next term. We've been doing stuff like this all along, but it gives you this in fractions and it took away the multiple choice. It's a great practice problem. So I look right here and I say, okay, I don't know how to add and go forward. So I'm going to subtract backwards. Okay, this is me testing whether it's arithmetic. I've done this over and over. Now, me personally, I can look up here and see what type of sequence it is because I do this all the time. This is our job. But for you, you look up here and see fractions and a mess of fractions. And you usually just shut down. I don't want you to shut down. I want you to try something. Let's see if it's arithmetic. Let's subtract backwards. Okay? So we did 1/6 minus 1/2. And this says common difference is subtracting a third. Okay? So going forward, we're subtract the third, subtract the third, subtract the third. Well, let's test it. Let's test it. You have to test it. Alpha y equals enter. One-sixth minus our suspected difference of 1/3. And we get negative 1/6, not 1/18. What that tells me is it's not arithmetic, meaning it is geometric. Well, if I can't multiply forward, I have to divide backwards. This is where things start looking a little bit messy. This is alpha y equals enter, 1/6 divided by 1/2. And we get a suspected common ratio of 1/3. So similar, but this time we think we're multiplying by a positive 1/3. And so we check it. I have 1/6 times 1/3, what we suspect to be the common ratio. I think I might have said difference again. If I did, I apologize. I got to really get better about that. And we get 1/18, which is what we were hoping to get. Let's just keep going forward. Times 1/3 should give me 1/54th. And then what it asks for is the next term in the sequence, which is 1/162nd. Some people have been giving me this as a decimal today. It's not wrong to give this as a decimal, but look at that. Which one looks cleaner? Not even which one looks cleaner. What was the whole problem in? It was in fractions. So we should probably do it the way the problem was listed. Alternatively, I had one person earlier today say, oh, I just multiplied the bottom number by 3 every time. That is what we're doing. But at the same time, we're multiplying the top number by 1. In other words, 1/3. That means the top number stays 1, 1, 1, 1, 1, because 1 times 1 is always 1. Anything times 1 is always that thing. But the bottom number is just multiplying by 3. It's just kind of a clever way to look at it. Number 12, find the common ratio. This is kind of taking a step back. Again, this sheet that you have is not multiple choice. It will be tomorrow. Mine is going to be multiple choice tomorrow. I just didn't want people to get into bad practice habits where they looked and said, oh, well, that was the only ratio that's a negative. Wink, wink, nudge, nudge. This is a negative ratio. So I just picked it. Well, that doesn't always work on the test. Sometimes it works on the review, but it doesn't always work on the test. So I took away the multiple choice safety blanket for your studying ability. And then I will return it on actual test day so that you have answers to choose from. That way, if you really mess one up, the answer probably won't show up there. It might, not all the time. However, common ratio should set off alarms in your head. This is geometric, meaning we have to multiply to go forward. That means I need to divide backwards to find that number, because those are some big numbers, okay? 2,500, actually I'm gonna just clear everything else so it's a little bit cleaner. 2,500 divided by 12,500. Oh, Mr. Stroh made a mistake. Mr. Stroh made a mistake. This is negative 12,500. Gives me a negative 0.2. Now again, decimals are not the end of the world. You'll see some later on. But for the most part, we've been leaving these as fractions, negative 1/5. So let's test it. 2,500 times negative alpha y equals enter, 1/5, and we get the 500 we were supposed to get. 3 numbers makes a sequence. We're good. You were right. Your common ratio is one of the answers being negative 1/5. Now, don't be scared if you got negative 0.2. You can just convert that and get the answer of negative 1/5. We just don't usually write ratios as decimals because they're ratios. That's a fraction sort of term, okay? A ratio of 2 numbers. So, number 13, given the explicit formula for an arithmetic sequence. Ooh, big words, big words. Explicit formulas, arithmetics. Find the first 5 terms, okay? So, I'm playing the matching game. I know I'm arithmetic, I know I'm explicit. I hop over to my formula sheet. Arithmetic, explicit. First term, common difference. Well, that makes the first term very, very easy to find. It's 18. But to go to the next term, we need to use our common difference. This is confusing because people are like, but Mr. How do you know it's a common difference? This is multiplication. Multiplying is the same thing as writing something in parentheses like that. And they just stuck it out on the end, but when it's a negative number, if they don't put that multiply sign, it looks like subtract 100, which is what we're doing, but that's not how the formula would work. So to get to the next term, we do our first term, 18, plus negative 100, same thing as minus 100. We get negative 82. I'm going to go ahead and just find the next several by adding negative 100 to my answer. So that's my second term, third term, fourth term, fifth term. Negative 82, negative 182, negative 282, negative 382. Box it up. You're done. Again, multiple choice tomorrow. Please be careful tomorrow, making sure that you're choosing the right one. There will be multiple answers that have 18 and then negative 82 on them, but you might have to go even 3 or 4 terms deep to differentiate between the right and wrong answers. Number 14, explicit formula for a geometric. Find the first 5 terms. Same song, second verse. We're back on the formula sheet playing a different matching game. Geometric, explicit, first term, and then our ratio is what is raised to a power here. So I know my first term, a sub 1. I know my common ratio. That means my first term has to be negative 2.5. And then to go every step of the way, I'm going to multiply by negative 2. So clear everything out. Negative 2.5 times negative 2 gives me a positive 5. I'm going to multiply that by a negative 2 because that's my second term. This would be my third, fourth, and fifth. 5. Negative 10, 20, negative 40. That's one of those oscillating sequences. Anytime we have a negative ratio, we tend to see these signs flipping back and forth. Number 15, given the recursive formula for a geometric sequence, find the first 5 terms. Same directions. Okay, I would expect these to be kind of mixed in a little bit tomorrow. Same sort of directions, first 5 terms, but this time different matching game. Geometric sequence, recursive formula. Geometric sequence, recursive formula. That means my ratio is out front, but there's no first term listed. That's because it's given to you in the problem. So I know my first term is negative 3, and every step of the way I'm using the common ratio of 5. So this would be negative 15. And again, if you want to do these by hand, great. If you want to go in and type them in, I'll show you how to do that individually on the calculator. Negative 3 times 5, negative 15. Negative 15 times 5, negative 75, negative 75 times 5, negative 375. I choose to do the times answer thing because it's quicker. But if you haven't quite caught on to that, I want you to be able to see one right here, okay, that I do it one step at a time, okay? So my first term was negative 3, second term was negative 15, third term, fourth term, one more to go, negative 375 times 5, negative 1875. That would be my first 5 terms of the sequence. Number 16, explicit formula, geometric, find the term named in the problem. Well, that would be the 12th. So we're going to have a lot of stuff going on here. All right? I would go and just grab that explicit geometric formula.